Hello everyone. Today we're going to learn about how to analyze displacement, velocity and acceleration with respect to time using a graph. Graphical representation of data gives faster interpretation, which leads to better analysis and faster decision making. It's said that a picture is worth 1,000 words. Instead of using a list of numerical values for the comparison of parameters like displacement, velocity and acceleration to time, we are going to learn how to plot and understand what this graph can look like. Let's start with displacement time graph. In this, time lies in the x-axis and displacement on the y-axis. Here we can easily make out that the object has a displacement of 10 meter in 1 second and 20 meter in 2 seconds, etc. If you see a displacement time graph like this that has a straight line parallel to the time axis, means that the body is at rest. This is because the body shows no change in position or displacement as time increments. If you see a displacement time graph that has a slanting line to the time axis, it means that the body is moving in a uniform velocity. The angle between the x-axis and the line gives us the information about whether the body is moving with a greater velocity or lower velocity. And in the final case, if you see a displacement time graph that is not straight line, it means that the body is moving with a non-uniform velocity as it moves unequal distances in equal intervals of time. Now, we know that velocity is nothing but the rate of change of displacement by time. The slope in a graph is the rate of change of y-axis with respect to x. In a displacement time graph, y-axis is the displacement and x-axis is the time. So from the above 2 points, we can infer that the slope of a displacement time graph gives you the velocity in that specific time interval. Let's take an example for this. Let's say that we need to find the velocity for a specific time interval in this graph. So what do? We have to divide the difference of the final and initial coordinates in the y-axis with the difference of the final and initial coordinates of the x-axis in that specific time interval. Here we subtract the two displacement values we get and divide it by the time interval, that is n time minus r time, and we get the velocity in meter per second. We also use this formula, that is y2 as y1 divided by x squared minus x1. Here in this case, 50 is the final coordinate and 0 is the initial coordinate in y-axis, and 0 is the initial coordinate and 5 is the final coordinate in the x-axis. So we get 50 minus 0 by 5 minus 0, which is 10. Moving on with velocity time graph. Velocity time graph shows velocity against time. If a velocity time graph has a straight line parallel to the time axis, it means that the body is moving with uniform velocity. If there's a velocity time graph that has a straight line inclined at an angle to the time axis, then it means that the body is moving with a uniform acceleration, which we'll be talking about later. If the line isn't straight, then it is non-uniform velocity, which implies non-uniform acceleration. There are two things that you can obtain from a velocity time graph. One is the displacement at a certain point and the other is the acceleration. To find the displacement in a specific time interval, we will have to find the area of the shape under that specific time interval. In this case, we will have to find the area of this triangle. Now, we know the formula of the triangle is half into base into height. So considering the base as 5 here, height as 50, here we get the displacement to be 125. Now for finding acceleration, we know that the acceleration is the rate of change of velocity. So we'll have to find the slope of the velocity time graph. Like before, we have to divide the difference of the 2 points in the velocity and in the time axis. In this case, we get 40 and 0 in the y-axis, 5 and 0 in the x-axis. So we get 40 minus 0 by 5 minus 0, which is 8 meter per second squared. That's the acceleration. Finally, we can talk about acceleration time graph. Y-axis shows the acceleration and x-axis shows the time. If an acceleration time graph has a line passing through the time axis like this, it means that the acceleration is zero, meaning that the body is moving with a uniform velocity. If an acceleration time graph has a line parallel to the time axis, it means that the body is moving with a uniform acceleration. Hence, the velocity time graph will have a line inclined to the time axis. If the line isn't straight, then it is non-uniform acceleration. We can obtain velocity from an acceleration time graph. The velocity can be obtained by finding the area of the shape under the given points. In this case, a trapezium. So the area is half into height into the sum of parallel sides. So the two lengths of the parallel sides here are 4 and 6, and the height being 20. So if we calculate it, we'll be getting the velocity as 100 meters per second. We have discussed displacement time graph, velocity time graph, and acceleration time graph in this video. Hope this video helped you in understanding these concepts. Thank you.